Now, good afternoon, students. Yesterday, we have completed the exercise how to find out how to use A inverse in solving linear equation by matrix method. Now, I am coming back to the exercise 3.4 that earlier we have left this exercise because at that time we don't know the meaning of inverse of a matrix. Now we know the inverse of a matrix. Now I'm again going to consider the question of this exercise 3.4. Now here using elementary transformation find the inverse of a matrix if it exists. Now in the last exercise we have find out the inverse of a matrix by finding out the cofactors, then finding the adjoint, then by finding the inverse of a matrix. Now but in this exercise we have to find out inverse of a matrix by elementary transformation. Elementary transformation is done by two ways. One is row transformation, another is column transformation. What it means? Row transformation means the operation that you have to perform only in rows. Either we can add the rows, we can subtract the rows, we can multiply by any row or column by a scalar quantity. The operation that you have to do to solve the question, all the operation will be done in the rows. Similarly, when we are going to do the elementary transformation by column transformation, we have to apply all the operation in the column. This thing you have to keep in mind. Whenever we are performing row transformation, we have to perform all the operation in the rows. Either we can add them, we can subtract them, we can multiply by any scalar quantity. But when it is mentioned, we have to find out the A inverse using column transformation. Then we have to apply all the operation in the columns. This method only you have to use when it is mentioned in the question. We have to find out the inverse of a matrix by using row transformation or using column transformation, or sometime it has been written that you have to find out the A inverse by elementary transformation. Either you can apply the row transformation or you can apply the column transformation. But in general, row transformation is easy to apply. Now let us see how to do the question. I have taken this matrix of order 2 and we have to find out A inverse by using row transformation. Now how to start the question? Let us do it. Now firstly I will find out the determinant of A. See either the inverse is existing or not. Now determinant of A is 5 minus 4 equal to 1, not equal to 0. So we can say A inverse exists. Now how to start it further? We know that first thing we have to write down, we know that A equal to IA. A equal to IA. Here in the row transformation always the pre-multiplication of I is there. In the row transformation always the pre-multiplication of I is there. A equal to I into A. Now putting the value here, A is this 5 to 2 1, I we know 1 0 0 1. This A will be as it is. Now let us do how to perform it. Now here in this question our main aim is to convert this matrix on the left hand side into I. We have to convert this matrix into I. It means we have to convert them into identity matrix, and all the operation we have to apply in the rows. Now here whenever I have to make it identity matrix, this element should be 1, this should be 0, this should be 0, this should be 1. Now we start doing it. Now firstly I have to make it 1. Now how to make it 1? Firstly I am doing it operating R1 to R1 minus R2. Operating what? R1 to R1 minus R2. Now here it becomes, I have to make it 1. I have to make it 1. Now here R1 minus R2 means 5 minus 2, 3, 2 minus 1, 1. One row, first row becomes this, second row will remain as it is. Only that row will be changed in which we are doing the operation. Other row or column will remain as it is. And same operation I have to apply on the right hand side also. What the operation that I am going to apply? I have to apply the operation on the left hand side as well as on the right hand side. Now first R1 is operating to, it will be read as R1 goes to, R1 is operating to R1 minus R2. When I am doing R1 minus R2, 5 minus 2, 3, 2 minus 1, 1. Second row as it is. Similarly here 1 minus 0, 1. 0 minus 1, second row will remain as it is. Now here, see the next operation. Now I have to make it 1. Now next operation we can do again operating R1 to R1 minus R2, because we know 3 minus 2 is 1. Then again operating R1 to R1 minus R2, 3 minus 2, 1, 1 minus 1, 0. Similarly here, 1 minus 0, 1, minus 1, minus 1, minus 2, second row will remain as it is. Now whenever we have to convert into identity matrix, one thing you have to keep in mind, when we are doing the row operation, we have to arrange first the columns according to I, and whenever doing the column operation, we have to arrange the rows according to I. Now here, when I operate this, it becomes 1 0 2 1. Now our first column, first element become 1. Now come to the second element. I have to make it what? I have to make it 0. Now what you have to do it here? I want to make it 0. So first I am operating step by step. Operating R2 to R2 minus R1. Operating what? R2 to R2 minus R1. So 2 minus 1, 1. 1 minus 0, 1. It become 1 1. First row remain as it is because we are applying the operation in only R2. Then first row remain as it is. Then applying the given operation in the R2. Similarly, here we are applying the operation R2 minus R1. So 0 minus 1, minus 1, 1 minus minus plus, it will be 3. Now here now I have to make it what? We have to make it 0, because again I am saying you, when we have to do the question by row transformation, we have to see the arrangement according to column first. Now we have to make it 0. Now whenever you have to make it 0, I can do 1 minus 1 is 0. Then operating R2 to R2 minus R1. Operating what? R2 to R2 minus R1. So first row as it is. Now 1 minus 1, 0. 1 minus 0, 1. Similarly, minus 1, minus 2, 3 minus minus plus 5. Now I have converted the matrix on the left hand side into I. Now we know when the product of two matrices is equal to I, then each one is the inverse of other. Now here the product of this and this matrix is equal to I. This implies A inverse equal to 1 minus 2 minus 2, 5. This is how to find out the inverse by using elementary transformation. Now in this question, this solution is very much tricky. We have to think wisely which operation we have to apply and do the calculation very much carefully. Now let us see the question again. Now I am explaining this question. You have to find out the A inverse by using elementary row transformation. Only you have to apply when it is mentioned in the question. Otherwise, we generally find out the A inverse by finding the cofactors and then adjoint, and then we can find out by finding A inverse equal to adjoint of A upon determinant of A. But if it is mentioned in the question, you have to do by elementary row transformation, then always you have to apply this method. Now first we have to find out A inverse. We will find out determinant of A. It is equal to 1, not equal to 0. So we can say A inverse exists. Now here let us see here. We know that A equal to I into A. Now when the row transformation is there, there should be pre-multiplication by I. Now it putting the values of A here equal to putting the value of I, identity matrix of order 2. This will A will remain as it is. Now as it is row transformation, we have to apply all the operation in the rows. Either we can add them, we can subtract them. It depends upon the requirement. Now I have to convert them into what? I. Now first I have to make it 1, then 0, then it is 0, then it is 1. Again I am saying when we have to do the row transformation, we have to convert them into I. Arrange first the columns. Now first operating I have to make it 1. I am operating it R1 to R1 minus R2, or otherwise I can also apply the operation what? 5 minus 4 is 1. I can also apply here R1 to R1 minus twice R2. Again then the question can be done. But I am doing it step by step because it is a very first question. Then applying here first R1 to R1 minus R2. So it becomes what? First row it changes to 3 1. Second row remain as it is. Similarly on the right hand side, first row becomes 1 minus 1. Second row will remain as it is. Now the next is, now I have to make it 1. Now I am operating R1 to R1 minus R2. Now again 3 minus 2 1, 1 minus 1 0. Second row as it is, similarly on the right hand side by applying the same operation. Now here I have to make it, now I have to make it 0. Automatically this element has been arranged. But our consideration is first arrange the column according to I. Now I have to make it 0. Now first I am applying it here R2 to R2 minus R1. So first row as it is, R2 minus R1. 2 minus 1, 1. 1 minus 0, 1. Similarly here again the first row as it is, 0 minus 1, minus 1, minus minus, plus 1 plus 2, 3. Now I have to make it 0. What I have to do? I am operating here R2 to R2 minus R1 because 1 minus 1 is 0. Now R2 to R2 minus R1. First row as it is, 1 minus 1 0, 1 minus 0 1. Similarly here minus 1, minus 1, minus 2, 3, minus minus plus, 3 plus 2 equal to 5. Now here the product of these two matrices is equal to I. This implies A inverse equal to 1 minus 2 minus 2 5. This how to find out A inverse by using elementary transformation. Let us see another question. There I have taken the question of order 2. Now I am taking the question of order 3. Now let us see the question. A is again a square matrix of order 3 and we have to find out A inverse by using row transformation. Now here again we will find out the determinant of A by expanding it by any row or column. We are getting equal to 1. Now it is not equal to 0, so we can say A inverse exists. Now here again we can write, we know A equal to, again we know A equal to I into A. Putting the value of A, putting the value of I, identity matrix of order 3 because the matrix on the both sides the order should be the same and A will remain as it is. Now here again I have to convert it into I. It means this is 1 already. I have to make it 0. I have to make it 0. Now what operation I am applying here? Operating R2 to R2 minus twice R1 because 2 minus 2 is 0. Operating what? R2 to R2 minus twice R1. We can do the calculation work in the rough also to avoid any mistake. Now R2 to R2 minus R1 operating here 2 minus 2 0 it becomes, 5 minus 4 it is 1, 7 minus 6 it is again 1 because 2 times, so 3 into 2 6, 7 minus 6 equal to 1. Then again I am applying this operation in same step. Now again I have to make it 0. Now when minus 2 plus 2 is 0. Now I am operating here R3 to R3 plus twice R1 because minus 2 plus 2 is equal to 0. Then operating R3 to R3 plus twice R1. First row will remain as it is. In the second row we have done the operation. Now we are doing the operation in the third row. So it is what? Minus 2 plus 2 0. Minus 4 plus 4 0. Minus 5 plus 6 equal to 1. Similarly the same operation we are applying here on the right hand side. Now our first column has been arranged. Now we have to consider the second column. Second column already this element has been arranged. This element also has been arranged. Only we have to make it what? 0. Now what I am doing here? Operating R1 to R1 minus twice R2 because 2 minus 2 is 0. Now operating R1 to R1 minus twice R2, it becomes, first row becomes 1 0. 3 minus 2 is 1. It becomes 1. Now the second row, third row will remain as it is. Then applying the same operation on the right hand side also, it becomes 5 minus 2 0. Second row and third row will remain as it is. Now our first column has been arranged. Our second column has been arranged. Now we have to arrange this the third column. Here 1 is already, only I have to make this is 0. This should be 0. Then what do we have to do? Let us see it here. Then I have to make it 0 and we have to make it 0. Then operating R1 to R1 minus R3 because 1 minus 1 is 0. And operating R2 to R2 minus R3 because I have to change the element of the first row and the second row. So then operating R1 to R1 minus R3 and R2 to R2 minus R3. Then it becomes first row R1 minus R3, 1 minus 0, 1, 0 minus 0, 0, 1 minus 1, 0. Then operating R2 to R2 minus R3, 0 minus 0, 0, 1 minus 0, 1, 1 minus 1, 0. And third row will remain as it is. Similarly applying the same operation on the right hand side. Again our aim is to make the matrix on the left hand side must be equal to I. So now again the product of two matrices is equal to I. This implies A inverse equal to the matrix on the right hand side. This is our answer. Now again you have to do the calculation work very much carefully, and one thing you have to take care, if I have arranged the first column according to I, when I am doing the operation on the second column to arrange, then the element of first column should not be changed. Otherwise, you will carry on this calculation and the question will never be completed. Only you have to take care if we have arranged the first column. When we are going to arrange the elements of the second column, these elements should not be changed. Otherwise, our question will not be completed. So, I can say this question is how much. However, these are the tricky question. We have to think wisely which operation we have to apply to get the matrix on the left hand side into the identity matrix. It needs a lot of practice also. Let us see another question. Now I am taking again is a given matrix of order to find A inverse using column transformation. Only when it is mentioned to perform by column transformation, only then you have to apply this method. Otherwise, you can do by the row transformation. Now here again, we will find out the determinant of A. 6 minus 5 equal to 1 not equal to 0. It means A inverse exists. Now it is the column transformation. The question will be started. We know that A equal to A into I. Here the post multiplication by I. In the row transformation is the pre-multiplication by I. Now, whenever we have to perform the column transformation, only we have to write down. We know A equal to A into I means the post multiplication by I. Now, putting the value of A here, this A as it is, and putting the value of I here. Now here, what? Now it is a column transformation. It means first we have to arrange the rows. In the row transformation, we have to arrange the column. But in the column transformation, we have to arrange the rows according to I. Now here, this should be what? It should be 1, it should be 0, then it be 0, it should be 1. What I have going to here, I have to operate all the operation in the column. Now we know that 6 minus 5 is 1. We have to make it 1. First, what I am doing it operating C1 to 3 times C1. Operating C1 to 3 times C1. It means we have to multiply each element of this column by 3. It becomes 6, 3, second column as it is. Similarly, applying the same operation on the right hand side, it becomes 3, it becomes 0. Second column will remain as it is. Now the next is here, I have to make it 1. Now next operation I am applying here C1 to C1 minus C2 because 6 minus 5 is 1. Then operating C1 to C1 minus C2. Now 6 minus 5 is 1, 3 minus 3 is 0. Second column will remain as it is. Similarly here 3 minus 0 is 3 and 0 minus 1 is minus 1. Second column will remain as it is. Now here our aim is we have to arrange, we have to make it what? Now I have to make it 0 and we have to make it 1. Then converted into I. Now I am applying the operation here. I have to make it what? We have to make it 0. I am applying operation C2 to C2 minus 5 times C. Because 5 minus 5 is 0. Operating what? C2 to C2 minus 5 times C1. So first column will remain as it is because we have to apply the operation in C2. Now 5 minus 5, 0. And 3, 0 into 5, 0. So 3 minus 0 is 3 as it is. And here applying the same operation here, first column will remain as it is. C2 minus 5 times C1. So 0 minus 15 minus 15. 1 minus minus plus, it becomes 6. Now what I have to do? Only I have to make it 1. Then applying here C2 to 1 by 3 C2. I am applying here C2 to 1 by 3 C1 because 3 divided by 3 is 1. Now again first column will remain as it is. Then dividing each element of the second column by 3. 0 by 3, 0. 3 by 3 is 1. Then similarly here first column will remain as it is, dividing the second column by 3. 15 minus 15 divided by 3 equal to minus 5. 6 divided by 3 is equal to 2. Now again the product of two matrices is equal to I. So we can write down A inverse equal to 3 minus 5 minus 1, 2. You can verify your answer also if you are having the time in the examination by finding the inverse by using adjoint of a matrix. Or moreover, in the second order we can easily, here when are going to these two elements are what? When are going to find out the matrix, we can therefore A inverse equal to 3 minus 5 minus 1, 2. The point I am going to tell you, I will tell you later on when I am going to find out the adjoint of the order 2. Now this is all about elementary transformation, the question of exercise 3.4. Thank you.